What's up, guys? So today we're working on a 2013 Toyota Prius hybrid. This car has been eating up coolant. We figured out that it was going into the combustion chamber. So the head gasket on this motor is leaking. So this is actually a job where we're replacing the head gasket. Now to replace the head gasket, you have to remove the head of the motor. So we've already done a lot of the disassembly here. Timing cover, water pump, mounts, fuel rail to get to this point. So I just figured maybe we do a quick little video, go over the different components of the engine and what they do as we disassemble it. Now, on the Toyota Prius, it's actually very common. The head gaskets leak on essentially all of them after about 150,000 miles on the third generations. Normally, people actually end up junking this car for this problem because the dealer charges an insane amount of money to get the head gasket replaced, something on upwards of $5,000. I mean, the car itself is only worth $5,000, so it doesn't make any sense to do it that way. But because I've done enough of these and can do it quickly, we're able to cut down the book times and do it a lot faster and save the customer money. So now that we have all this taken apart, I think the first thing we can talk about is the timing chain and variable valve timing system. So if you come over here on this side. So what Toyota's done here is they've stuck a variable valve timing gear on the intake camshaft. The exhaust is not variable valved. So this is your timing chain. The timing chain goes all the way down and it connects to the crankshaft. The crankshaft is what connects to the pistons. So as the combustion's firing, it drives the pistons down. That spins this crankshaft, which is connected to this chain, which comes all the way up and connects to the intake camshaft and exhaust camshaft. Now, so you have your intake valves on the front and your exhaust valves on the back. And that's being driven again by this chain. Now, it's variable valve timing because of this little gear right here, which is hydraulically driven. So you can see these little holes right here. Those are ports for oil pressure, which actuates the variable intake camshaft. Now what that does is it enables the computer of the car to change the lobe duration, essentially the camshaft profile, which enables the engine to go from an economy version of running, which saves fuel, but then also being able to change to a more aggressive profile, which can increase horsepower. So this little cam gear is actually moving back and forth and changing its position to either go from an economy mode for more gas mileage or for a performance mode for better fuel. So now, next what we're going to be doing is, in order to get this head off, which is this part right here, so you have the crank, the lower block, the crankshaft is housed in the lower block, and the block is the bottom part and the head is the top part. So after we take the head off, I can show you what I mean by that. But essentially you have the two sides of the motor. You have the block and the head. Now, in order to take this head off, we have to take these camshaft caps off. So the camshaft caps are what keep the camshafts bolted into place. So what you have inside of here, so the camshaft rides in this journal, and see here you have these little holes. These are oil galleys. So not only does the crank drive the camshafts, but the crank also drives the oil pump, which is flowing oil through this entire piece, through these holes, and actually shoots oil in a very tiny little thin film right here on this bearing, which rides on top of this camshaft right here. So as the camshaft is spinning, there's constantly a thin layer of oil being supplied, because remember, this camshaft's spinning at, let's just say 4,000 RPMs. It's metal on metal. If it was dry, it would just instantaneously melt. So we need to keep it lubricated so it can last for a really long time. So this is the camshaft removed. Here on the camshaft, you can see we have the journals right here. This is where they spin in the cam journals. Again, that's where the lubrication comes from. Here we have the lobes, okay? So the lobes are what is actually driving the valves up and down. So as the camshaft's spinning, you see, if you look at the lobe, there's a low point and a high point, and they're kind of offset. So as this thing's spinning, it's pushing down here on these rockers and opening and closing the intake valves. And that is being precisely timed to the crankshaft by the chain. So it's a mechanical timing you have that is driving the valves. So not only do you have the intake valve driving the intake valves, at the same time you also have the exhaust camshaft driving the exhaust valves. So here you can see the top point of the valve. When this spins around and gets to the high point, it will push down those valves and open it. And these two are synchronized on each stroke such that you have the 4 strokes, because this is a 4-cycle engine. So you have your intake, compression, power, exhaust. So during all of those successive strokes, you're doing the 4 cycles. One is to intake the fuel and air. The other is to compress it. And then you're going to fire that off for the power stroke. And then the 4th stroke is to exhaust it, which is to send it out through the exhaust. That's when the exhaust valve opens. The head is an aluminum construction, so it's lightweight. That's obviously it's a Prius, so we're going for good gas mileage, so we want to keep the weight down. It's all aluminum construction. These cams are actually steel, and you know what they do from the factory is they line hone these things. So a machine comes in and down to the thousandths of an inch comes through here and line hones to make this camshaft be able to be, I mean, the precision you have to be able to have these things run is pretty crazy. So, I mean, nobody really does it better than the factory, to be quite honest with you. And then over here, what we have is, here we have a little Hall effect portion of the camshaft. So we can't really see this. What you can see here with this valve cover, there's a little sensor right here. Now this is the camshaft, more specifically, the intake camshaft position sensor. That sensor is flat. It's what's known as a Hall effect sensor. Maybe in another video I'll go into how a Hall effect sensor works. But essentially this is just a magnet with electricity running through it. And every time, put this right here for reference, as the intake camshaft is spinning, it's spinning right next to this sensor. Now if you look here on the end there you you go, low point and a high point. So as it's spinning, when that high point gets near the sensor, it sends a signal to the computer about the position of this camshaft. So it goes high, low, and actually it's timed because you can see there's a different spacing here. So the longer the spacing, the longer between the signal input. That way the computer can instantaneously know the position of this camshaft. Now it needs to know the position of the intake camshaft because of this variable valve timing, which is happening over here on the front end. So it's a pretty crazy little system. But these little lobes right here, these little steps are what enable the computer to be able to translate the mechanical position of the camshaft into an electrical signal so that the entire engine can be run properly. All right, so next we're going to remove all of these cam caps and then take the camshafts out. We'll put those aside. Get this head off, which is pretty much the last step at this point. We have to remove the head bolts. So that's what we're going to do next. I'm going to remove these head bolts and then I'll bring you guys back for the removal of the head. So we've removed the head. What I've done is I have taken the head and I flipped it up. So the head was normally sitting down flat. I flipped it up here so we can see what's going on. So on the top of this head was where the camshafts were spinning. That actuates these valves. So we've got intake valves in the front, the big ones, and exhaust valves in the back. These valves come down this way and they open up. So the intake valve opens to let the air and the fuel in, and the exhaust valve opens to let the exhaust out. Now, here's the head gasket. So, if we look very closely at this head gasket, we can see this wear right here. So this is like a coating they put on the head gasket. It's called an MLS, a multi-layer steel head gasket. So multiple layers of steel with, it's essentially like a plastic coating they put on it to seal the coolant and oil. Right in here, see right in here, this point right here, we can see that the plastic part of the gasket has worn, and that's where the coolant has been able to escape through the head gasket. So, because that head gasket's bad, if we look at these pistons, if you look at the color variations, you can see how clean this piston is here. This one's pretty black, that's carbon, and this one's very clean. What happens is when the coolant leaks from the coolant jacket, which is in here, coolant sits inside of these coolant galleys here. So this is an open deck design. The coolant leaks through here and then goes into the piston while it's running. Now when coolant or water goes into the combustion chamber while it's running, it actually cleans all this carbon off. So that's how we know this is the cylinder that it was leaking into. It was this cylinder and partially this cylinder over here. And that was also evidenced by the head gasket wear. So we're going to replace the head gasket. Some points to note, obviously this is an aluminum block, so it's aluminum block, aluminum head, very lightweight design. And then also what we can do is we can rotate the crank. So when the crank is rotating, these pistons are going up and down. And that is what's driving the camshafts as it's spinning. So what's happening is you have this little combustion chamber up here and this little combustion chamber in here, and it's a perfect seal. So it's like a little bottle inside of here. And what happens is when you set off the fuel and air mixture, it creates an explosion which pushes the piston down. See that? That's how you drive the engine. So every time you have an explosion or a power stroke, it pushes down on the piston, which causes it to rotate. Now it's bottom dead center and top dead center, so I can't push it. But so that's what's going on. The power stroke, you have an ignition event, explosion that pushes down on the piston. Oh, that's not in a good spot. So at different points on the crank position, you have varying levels of leverage. So it makes it easier or harder depending upon the position. But so anyway, so you get the point. So there's a combustion explosion that drives the piston down. And that's how it goes. This whole thing is synchronized to these valves. And that's what makes the engine run.